Welcome, everybody. I thank you all for joining. It's great to have everybody joining us. Presentation today, fixed wireless access, FWA technology. Okay. The fixed wireless access name is fairly new. The mobile phone companies kind of invented this. Before them, the technology has been available. We called it fixed broadband access, and it's been provided by WISPs for the past 20 years or so. I'm going to split the presentation into 6 sections. First of all, what is fixed wireless access? A little bit about wireless network infrastructure. Then I'll tell you about subscriber management technology, followed by planning a WISP business startup, expanding an established business, and then products and technologies. If you have any questions, make a note. You can put them in the chat box or right at the end. You can unmute yourself, and I will have a few minutes for questions and answers. Okay? So one of the questions I get asked frequently, how do I start a WISP business? We work with bigger companies, telcos, who ask us about helping them to provide fixed wireless access, but also people who would like to start in a WISP business, maybe people who don't have deep technical skills. Most WISPs in the USA were started by people who have very, very deep technical skills, probably many years working with IT, Cisco products. But that kind of limits the number of people who can start a WISP business. And today we have a lot of products that are fairly plug and play products from companies like Ubiquiti, and also plug and play subscriber management systems. So it's easy now for somebody with technical knowledge that's not so deep to start a WISP business, and I'll tell you how during the presentation. First of all, there's a book that accompanies this presentation. This is a free download, so either contact me or contact Valia, and we'll get you the link to download this. It's available in English and Spanish. Okay, so this is about a 300 and so page book that gives you a lot of technical detail about starting a WISP. Now, when we talk about fixed wireless access, we're talking about what we call the last mile, which is the technology that we use to connect a home or an office. And there are several types of technology. Probably the most familiar is ADSL, over twisted copper pair. A technology that was developed to work on top of the telephone system, the infrastructure that was installed, and this began rolling out in the 1990s. It was a great service at the time. It's today, by comparison, it's slow, and the distances are short. You can basically connect a home maybe 3 miles from a central station. We have also internet connections over copper coaxial cable using DOCSIS. Very popular. The cable TV companies adopted this and rolled out internet service to many customers. Once again, distances are limited. Copper is not a terribly good medium to transmit data over long distances. And so it's basically a technology for urban areas like ADSL. We have today optical fiber, GPON over optical fiber, gigabit speeds. This works over longer distances, still suitable for urban areas, not so much for rural areas, because of the cost. It's a new infrastructure, and so it has to be installed from zero. What happened is that a couple of years ago, the government allocated around $45 billion for companies to start installing fiber cable, optical fiber cable for subscribers. And so some of that was in the form of loans, some in the form of grants, depending on the type of customer that was being connected. We have wireless technology as well. We have unlicensed and licensed. Licensed is the fixed wireless access that mobile phone carriers provide. They purchased rights to using a certain band of frequencies, and so they provide that service over those frequencies. And today, anyone can get 5G LTE, or 4G LTE or 5G, providing that they're within a reasonable distance of a tower. There are many parts of the USA that are not within distance of a tower, and so they're not covered by that. The unlicensed Wi-Fi 5 or Wi-Fi 6 technology is over the 5.8 and 6 gigahertz frequencies. That's a much lower cost technology to implement, so the service ought to cost less. And this is the service that is offered by wireless internet service providers. In addition to that, we have a couple of wireless technologies satellite-based. So we have a geostationary satellite, HughesNet, which has been around for quite a few years, and a more recent innovation, Starlink, which has low Earth orbit satellites. Both these are more expensive than the fiber or the fixed wireless access. They do offer access anywhere on the surface of the planet, so they cover areas where the other technologies don't cover. So fixed wireless access, also called fixed wireless broadband or fixed broadband access, relies on having a tower reasonably close, within a few miles, put an antenna on the premises. The antenna connects to some sort of wireless device which receives those frequencies and then converts that into internet for the home using Ethernet, either wireless Ethernet or wired Ethernet. And the tower can be a telco 5G tower, or it can be a tower built by a WISP with unlicensed antennas on the top, and that tower has to connect to the internet. And so there are various tower connection technologies that can be used. Now, this type of technology is very common all over the world. The installation of technologies like fiber is very desirable, but not everybody has access to that. But wireless is a technology that many people have access to. So when is fixed wireless access the best choice? Well, there are reasons why people are not going to connect it with fiber. It could be because there are physical obstacles like rivers or some obstacle like that. It could be because the person is beyond the limit of the fiber connection. In most cases, it's because the installation of fiber is simply not economic, and in fact, probably the location doesn't even have phone connections. Fiber to be economic means that you have to be able to recover the cost of installing that fiber within a reasonable time frame, maybe 2 or 3 years. However, it's an expensive technology to install. It requires digging trenches or putting cables on poles, and so it can only be recovered when there are a large number of subscribers who can share the connection. And in rural areas, that's often not possible. So we look to fixed wireless access as a method of connecting these customers. either 5G towers or unlicensed using provided by a WISP. Wireless infrastructure is a range of technologies, not just one technology. There are the telcos have basically two types of technology: 4G LTE, which is the older type of wireless connection, and 5G, which is a different technology, requires different equipment. In the United States and in Europe, most telcos have spent the money to upgrade the networks to 5G, but that requires many billions of dollars. It's an expensive upgrade. A lot of other telcos around the world that are still operating 4G LTE, they don't have the resources to upgrade to 5G. And so when we work with customers outside the USA, we're talking about 4G LTE type connections. The unlicensed connections, Wi-Fi 5, Wi-Fi 6, that type of equipment is available from many different vendors. We're going to get Wi-Fi 7 pretty soon, which will increase the speed of the connection. And probably Wi-Fi 7 is going to be available next year. Right now, a few manufacturers are providing equipment for evaluation, but it's going to be mainstream next year. And so the wireless circuit requires a tower, an antenna on a tower, which is usually point to multi-point. And then we have a wireless receiver at the customer site, which is usually called a client premise equipment, which goes back many years when wireless was first used. And this can give you a range of several miles. The point to multi-point antenna is not directed at any one customer. And so we can get a line of sight range, very important. Those frequencies only work when you have visibility between the two antennas. So we set up a line of sight connection. And if we want to go further than maybe 5 miles, then we have to put a directional antenna on our tower and build a point-to-point connection. And then if we have a good visibility between the two locations, we can extend the distance to 10 or 20 miles. If we don't have any visibility from the user site to a tower, and then the only option remaining is the satellite network. 5G is pretty common now. All the telcos are offering this. AT&T, Verizon, very popular. Basically, you can put a wireless router in your home, which has an antenna inside it. You can connect a computer with Ethernet. It also has a Wi-Fi connection. And that will communicate to a tower maybe a couple of miles away with the antenna in the unit. If you want to connect further, you've got to put an antenna on the roof, like those two Yagi antennas shown. And in that case, you can extend the distance past 5 miles, maybe if you get a very good line of sight connection to the antenna, maybe up to 10 miles. And the service depends on the vendor. AT&T and Verizon put data caps. Right now, T-Mobile has unlimited data. And so basically the choice of the consumer is the availability of a tower within a reasonable distance that the consumer can connect to. It's worth mentioning that if you put a good antenna, you're going to get a faster data rate. And so if you have a unit in the home with the antenna inside the unit, then putting an external antenna is probably going to double the data speed to the tower. And so it's worthwhile in that type of installation putting an outside antenna, even if it's close enough to get a connection. The cost is reasonable for that circuit. There are plans out there from T-Mobile around $50 a month, which is in the same ballpark as the old DSL systems. Unlicensed requires the wireless internet service provider to build a tower. Some wireless internet service providers use the same tower that the mobile telcos use. Why? Because the companies that build the towers rent space, and so the mobile telcos can rent space for their antenna, but WISPs can also rent space for their antenna. That's a more expensive option, but you do get a tower with an internet connection and with power, so you get a lot of services provided. If the WISP builds a tower, then they're going to put a point to multi-point antenna on top of the tower. Obviously, the tower needs to be at a high point so that you get line of sight to as many potential subscribers as possible. And then we have to connect that tower back to our point of access to the internet, which could be at our network operations center. So we have a wholesale connection, and we might connect the tower using a point-to-point wireless link. And so we can connect the point-to-point wireless link, again with line of sight over several miles. Excuse me. So in this situation, each home has a CPE wireless, connects to the point to multi-point wireless, and then connects back on a point-to-point link to the wireless network operations center. And one WISP might have several towers connecting back to one network operations center, and using frequencies such as 5.8 gigahertz. At the bottom there, I put 8 gigahertz, but that's a typo. It should be 6 gigahertz, which is a fairly recent band. To get a further distance, a longer distance to the subscriber, we can set up point-to-point links. So we put a directional antenna, which gives us a much higher gain on our tower. So we need one directional antenna for each subscriber, but we can then connect the subscribers over many more miles. We can also give the subscriber a much higher data rate, because we can get point-to-point links licensed at 11 gigahertz or unlicensed at 24 or 61 gigahertz. And so that will give us data rates in excess of 1 gigabit. So that's competes with fiber fairly well. And the cost, of course, of the wireless link is much less than fiber. Now, connecting that tower back to the internet somehow, well, one option is to have a fiber cable that goes to the tower, and that fiber goes back to telco, point of presence. We can set up a point-to-point wireless link to our location or to a telco location in order to get wholesale broadband access. Or we have a new contender, which is the Starlink satellite antenna, which we have a lot of our customers using right now. Starlink have several options. One of them is a business antenna. Gives you a higher throughput up to 500 megabits, a more expensive antenna. It's about $2,500, costs $500 a month. But if you have no other option, it allows you to provide a pretty good wireless service to maybe 20, 30, 40 subscribers from one tower. So you can actually share that between quite a few people. So those are the basic three options to connect a tower. The mobile towers usually have a fiber connection. The companies that build the towers for mobile phone companies, they need a data connection as well. And so they come with the power is connected to the tower, a fiber connection. And the tower also has backup power and network equipment ready to plug in the telco's equipment or the WISP's equipment. The WISP might want to put a tower where there's no power, no data. Why do we want to do that? Because we want to put the tower on a high location to get as much visibility as possible for the maximum number of potential customers. And so we can actually power the equipment on the tower from a power supply that consists of a solar panel, wind turbine, and battery. And Flytech have this equipment from one of the suppliers. And so we install this at the tower. We can power all the equipment on the tower, and the tower needs only a wireless backhaul to the central station. The next issue is managing subscribers. We've talked about the infrastructure to connect the subscribers to the network, but we also need to turn that into a business by managing the subscribers. We need to be able to not only connect the subscribers to the network, but we also need to bill the subscribers. And also, if the bill is not paid, we need to be able to disconnect those subscribers. And so we have a system of subscriber management, which consists of software plus a broadband network gateway. Now, all telcos have a broadband network gateway to manage the data connection. AT&T has one for fiber or DSL. All WISPs have one type or another of broadband network gateway. A lot of WISPs with technical skills build this using a PC type computer. It's available off the shelf for those who want to build a plug and play system. The software which manages the business has a number of different functions. I mentioned billing. So we need to be able to send invoices to subscribers and receive payments for subscribers, disconnect subscribers if they don't pay. We want also a sales function, because we're going to have people who are speaking to potential customers and then signing up, adding them to the system. We also have network technical issues. We have technical staff who are connecting new subscribers and activating them onto the network. But we also want to monitor the network and know when a failure occurs in order to repair that failure. And finally, support. We have features that provide a connection for the customer to a support person, or call a support person, and that support person has access to information about that customer. That support person can test the circuit out to the customer and verify why a customer doesn't have a network connection, if that's what the customer is complaining about. And finally, there's managerial functions where a manager might decide to set the rate plans, the amount that would be charged to a customer for the service. So that gives you an overview. The diagram there shows the various components in the network, and the software might be in a server at the ISP site. More often than not, it's a cloud service. So WISPs would use a service like visp.net, or EasyWisp, or some service like that, which connects to the broadband network gateway. That could be a router, like a MikroTik router, or a specialized type of product which gives you a better performance in order to manage those subscribers onto the network. This diagram shows that in a little bit more detail. You can see in the middle of the diagram there, we've got the broadband network gateway. On the left-hand side, we've got the subscriber infrastructure. On the right-hand side, we've got the wholesale provider, the wholesale network infrastructure. And we have various functions there. The manager that I mentioned is at the bottom right, who is monitoring the system and deciding how much clients are going to get charged. We have the financial person above him, who is sending out the invoices to customers, ensuring that customers pay, and ensuring that the system is updated with those payments. Above that, we have the salesperson. The salesperson is adding a new customer to the system, and that triggers two things. First of all, it adds that customer as a subscriber to the subscriber database, and also initiates a work order for the field service technician, because we have to install the CPE wireless at the location of the customer. So the field service technician has to roll a truck, install a piece of equipment, test that it's connected, and then activate the customer. At the top left, we have the support person, very important. We might have a customer relationship management system, which is a software which allows us to manage subscribers and gives subscribers access to information. And so the subscriber, even if the subscriber doesn't have a connection to the internet, the subscriber can access the CRM system, can check on payments, the situation of the account, and also open a support ticket with the support person who can then answer that question. So that gives you an overview of the business management. The difference between a very small WISP and a very large company like AT&T is basically in the scale. The functionality doesn't change much. That type of system might be an EasyWISP cloud service with a gateway, broadband network gateway installed at one site or at a tower. In the case of AT&T, they have various types of infrastructure spread all over the country. In fact, not only in the USA, in other parts of the world as well. And so they have to manage multiple types of infrastructure. They have wireless, they have DSL, they have fiber, plus they have several different products. The WISP has one product, which is internet connection. AT&T have that, but they also have TV, which they provide over broadband. They have telephone service, which they also provide over broadband. They have even home security services, various other types of services. So they can provide you with managed Wi-Fi, provide a business with managed Wi-Fi. And so you can see that that's the basic way that a service provider works, and the difference is in the scaling. As a WISP can start with one tower, with one broadband network gateway and a cloud management system, and then expand that to multiple towers over a large region, through a state, through several states. The broadband network gateway is basically a piece of equipment with several stages of control. First of all, when the customer connects, we're going to check that that customer is who that customer should be through an authentication process, and enable the subscriber. We want to activate the subscriber based on the status of the billing system, and apply the access rules. That might be speed limits. So when you get an internet service, you might want 100 megabit or 50 megabit, and the telco will charge you for the speed service you get. In the case of 5G, it's basically the maximum speed. There's no speed service. On the other hand, when you buy fiber, when you get a fiber service, you can choose the speed you want. The command and control for the broadband network gateway is sent over the internet. So the broadband network gateway is also updating the software on the status of the network, reporting back about subscribers that are connecting to the network, and also gathering information about the operation of the network. So that's a piece of equipment. It can be a general purpose router, although a general purpose router will cause a very high overhead on the software management system. Dedicated equipment like the EasyWISP does a lot of processing. In fact, it downloads the subscriber database for that particular tower. And so it does a lot of processing, transaction processing, without communicating with the server. And it does what we call the AAA functionality, AAA, authenticate, authorize, and accounting. So that's very, very common. All telcos have this. This shows the administration interfaces. I mentioned those roles within the company: billing, sales, support, the managerial, and the network. For a very small WISP, that might be one person who's doing all that. The same person who put the antenna on the tower and is also installing the CP wireless units in client premises. Really, a WISP can be a single person operation for a village or a small town. Once that expands, then the business requires more people, and those people will fit into dedicated roles within that business. Now, plan a WISP startup. The economics of starting a WISP really depend a lot on how the service is going to be provided, how many customers. But I did a little calculation here for one tower. I didn't include all the costs, but for example, if we're going to set up a tower with a Starlink business backhaul, then we're talking about $2,500 for the antenna purchase, $500 for the monthly charge. We have a lot of WISP customers who are doing this because it's the only way they can extend their area of coverage to more subscribers. That will give you a data capacity maybe up to 500 megabits a second. And so maybe we can sell plans of 50 megabits to subscribers, and we can sign up 50 subscribers. And you might say, well, you're oversubscribing, but this is what telcos do. And there's a name for this. It's called a contention ratio. So if we set up a 5-to-1 contention ratio, then we're overselling the service. But we're betting that not everybody is going to connect at the same time, and not everybody is going to use the maximum data speed. WISPs generally have a rule of thumb that the average data speed for a household is about 4 megabits a second. So even if they have a 100 megabit circuit, they're using on average 4 megabits a second. People might use more if they're downloading a large file, but that will last a few seconds. But typically a family of four may be watching Netflix, gaming, and checking emails. We're looking about 4 megabits a second. So we can easily increase that contention ratio. If you're AT&T and you have a 100 gigabit speed backbone, you can probably go to a 50-to-1 contention ratio, which they do. So if we charge $25 a month for this 50 megabit service, then we're looking at gross sales of $1,250. So that'll give you a $750 margin. Obviously, you might want to charge more because you've got to amortize the cost of building that tower, installing the point-to-multipoint equipment. And so it may cost you $10,000 to build a tower. It may cost you another $1,000 to install the point-to-multipoint wireless equipment. So all that has to be taken into consideration because we'd like to pay back the investment cost within a maximum of 1 or 2 years. And so these are the calculations we have to do to see if the business is viable. And also, maybe we have alternatives to connect to the internet. Maybe we can install a fiber connection from a provider, or maybe we can install a point-to-point link to another location where we can share access to a 10 gig fiber. Now, the book that I recommended has one chapter just describing how to prepare a business plan, and it goes into a lot of detail. But basically, it covers what I've been talking about, looking to see if the business is economically viable. So how much can you charge for the service? How many prospective customers do you think will sign up for the service? How much is the initial investment cost? How much is the ongoing investment cost? And so you put this into a spreadsheet and come up with some numbers. You come up with the profit and loss statement, and you come up with a time to amortize the investment. And so those numbers have to be pretty good in order to ensure that the business is viable. So this is the homework that has to be done. Not all WISPs do this. A lot go by rule of thumb and guesswork, and so some fail and some are successful. But generally, good planning helps make a successful business. Now, once you start in business, basically it's easy to expand. If you have a tower, you can put more wireless equipment on that tower, provided you can get a faster backhaul service to the tower. You can set up new towers to expand geographic coverage to sign up more subscribers. And so when you're looking at the income, you really need an income sufficient to continue expansion. So you want part of that income to be available for reinvestment, to build more towers, to add more subscribers. And if you're a WISP, you know that if you can add a lot of subscribers, you become an acquisition target for a big telco, which is maybe a good place to be. So we can expand to multiple locations. We can put a broadband network gateway at the tower. We can put our towers anywhere we want. We can connect to the internet however we want. Maybe one tower connects with a Starlink, another tower with a point-to-point link to a central location that we have. Maybe another tower has fiber because it's a tower that was built for telcos. And so we have a range of possibilities, and our objective is to be able to give a wide area of coverage so that we can sell to the service to as many subscribers as possible. We have to be price competitive when we do this. We cannot spend a lot of money building the infrastructure because we have to be able to charge less than maybe some alternatives. We have to be cheaper than T-Mobile, for example, if we're in the same coverage area. I did mention that if you look at a map of the USA and look where there is 5G or 4G LTE coverage, you'll see that most areas of the USA don't have coverage, and those are all rural areas. But there are villages and towns in rural areas, and so those are potential customers. Outside the USA, of course, there's a huge opportunity in just about every country. We work with people in Latin America, Caribbean, and so the potential to provide these services is huge. Huge demand for internet access and very little infrastructure to provide that. Now, we can also add fixed wireless access to existing systems. It might be a telco system that provides 4G LTE, and we want to add fixed wireless access. We can do that either over licensed frequencies or unlicensed frequencies to subscribers, and we can use our existing billing system. We really don't want to route all the connections we're making back to one location which has a broadband network gateway, because that means spending a lot of money upgrading our existing infrastructure. What we'd like to do is build towers and be able to connect them to a point of presence that is lowest cost, but then manage that service through our existing billing system. And so this is what a lot of telcos do. If they're especially telcos that can't afford to upgrade their networks to 5G, which is a lot of telcos outside the USA. And so what can be done, for example, a 4G LTE tower that's already at capacity with mobile phone services, we can add an extra antenna or antennas for 4G LTE licensed or ISM unlicensed. We can increase the capacity of the fiber to the tower, because fiber can be operated at any speed. It just depends on the equipment at each end of the fiber. We can put a broadband network gateway at the tower and manage that through a billing system like Amdocs, which has an API for third-party broadband network gateways. So that the software already has this feature. So we can put our subscribers on the Amdocs system, and we can add as many towers as we want. A WISP might want to do this through another billing system, for example, rent space on the same tower, use the same fiber connection that the telco is using, but then manage the broadband network gateway through the WISP's own software. And so when we look at the data rates, 5G, 250 megabits per second, even more maybe. Some telcos claim up to 350 megabits per second. 4G LTE, 100 megabits per second. DSL much less, but that's maybe the option when fiber is not available. And so a telco that provides already mobile phone service can easily upgrade the network. When we talk about upgrading a tower for 5G, we're looking in the millions of dollars, whereas upgrading a tower with 4G or ISM can cost, in the tens of thousands. So it's a much cheaper way of upgrading to add many more subscribers to fixed wireless access. Now, products for fixed wireless access. Well, it really depends on the technology that you want to use. The backhaul technology of the tower, the method of communicating with the customers, whether you're a telco that owns licensed spectrum, or if you're a company that rents licensed spectrum for a telco. Or else you're going to use the ISM bands, the unlicensed bands, which is 5.8 and 6 gigahertz. And so, depending on the technology you want to use, then that determines the products that you're going to purchase. And so, Flytech, for example, has a whole range of products. You're looking at the point-to-multipoint wireless access points, the CPE radio to install at the subscriber's premises. You have other types of point-to-point links, fiber equipment if you have fiber connections at the tower, also the broadband network gateway equipment, which includes the billing system. And so you select these components based on the technology that you want to use to deliver the service to the customer. Okay, well, that brings me to a close. I'll just mention that we have internet consulting services. We can help customers with fixed wireless access and other types of communications technology. We also have a range of cybersecurity consulting services as well. There's my contact information. If you want to get in touch with me, you can send me an email and ask about the book. Okay, so I'll stop the share, and then if anyone has any questions to ask, I'd be very happy. You can either type them into the chat box or else unmute yourself and ask me the questions. So does anyone have any questions they want to ask? No questions? Okay, well, if you think of something later, you got my contact information. You can send me an email.
Yeah, I have a question. Sorry.
Oh yeah, go ahead, Freddie.
I was trying to unmute myself. I couldn't do it.
Okay, go ahead, Freddie.
No, my question is about the gateway.
Yes.
It's my understanding that there's some other options, maybe using a router, a MikroTik router, instead of that gateway. Is the question is about the same functionality? Well,
if you want to use a MikroTik gateway as a broadband network gateway, then you have to use a software that can manage a MikroTik gateway. And so, for example, you have softwares like visp.net, visp.net. Now, if you use a MikroTik gateway, you've got to use a pretty substantial router, because the MikroTik routers don't have the greatest performance. But if you go that method, the MikroTik router doesn't have a lot of intelligence in the box. It has to communicate with the server for every single transaction that happens. And so you're going to pay more for the server. So at that end of the scale, you can use a MikroTik gateway, a MikroTik router as a broadband network gateway. But with Visp.net, you got to be paying about $1.50 per subscriber per month. Okay. So if you have a lot of subscribers, maybe it will go down a little bit, but you have a pretty high monthly expenditure. So if you've got several hundred subscribers, you might be paying $1,000 a month. At the other end of the scale, the EasyWisp is a more expensive broadband network gateway, but you get to use the cloud service for free. There's no charge for that. So it costs more than a MikroTik router. But if you compare the two over a year, the EasyWisp is certainly 1/4 of the cost, okay? Because you don't have the cost of paying per subscriber. So it's a choice you make. The Visp.net is certainly a very sophisticated system with a lot of features. The EasyWisp system is much more basic with less features. Enough features to run a business without doubt. So you really have to evaluate what your costs will be to determine exactly how you're going to manage the subscribers. Does that answer your question, Freddie?
Yes. Thank you.
Okay, good. Does anyone else have any questions? Oh, I see in the chat room. Oh, yes, Tirana. That's very interesting. Somebody Pedro asked about Tirana. Yeah, they have a very interesting technology. It's an Indian company. They have an office over in California. And what they've done is to have a point-to-multipoint technology with a much further range. Now, if you're familiar with the Starlink antenna, it's a flat panel antenna. How do they get at the same power as Wi-Fi? How do they communicate with a satellite that's 300 miles away? Okay, well, they do it with the design of the antenna, and it's a beam focusing technology, which in the case of Starlink, they have about 1,250 tiny antennas where you adjust the phase in order to focus the beam. And so you get a much longer distance of communications. This is what Tirana do. They have a point-to-multipoint antenna with a phase array. And so they can communicate over much longer distances. You've got to remember that most of the Wi-Fi gear that we have as a very basic antenna. It's what we call a half dipole antenna, maybe with a reflector. And it's the same antenna that Marconi was using back in 1892 to do his test communications in the UK. So antenna technology really didn't develop much. So the basic antenna that we use for Wi-Fi is pretty awful. It really does not have a long range. If you're in the satellite business, you can't use an antenna like that. You have to go to a phased array antenna in order to get the range. And so what Tirana have done is to package the phased array technology into a point-to-multipoint antenna package. And so that will give you much better performance at the tower. So they also use some license frequencies in the 700 megahertz range, which the FCC sold off part of that spectrum to telcos, but they reserved part of that spectrum to sell licenses to small WISPs. And so you can actually use licensed technology, which is obviously free from interference, for a much lower cost. A telco would maybe pay billions of dollars for licenses, whereas for a few $100s you can get a license in that frequency band. And 700 megahertz is what we call near line of sight, which means you can communicate if there are trees in the way. So Tirana, yeah, great technology. I'm very impressed with that. Now, Inusa asked about what are the alternatives for EasyWisp. Well, EasyWisp I'm involved with that project, so I know a lot about that. That has a couple of different broadband network gateway offerings, one 250 megabits per second and one gigabit. And usually if we're building point-to-point links to towers, we're probably building those links at 100 megabit, maybe 150 megabit, using Wi-Fi 5 or Wi-Fi 6. And so we're okay putting a low-cost broadband network gateway at the tower that's 250 megabits. On the other hand, if we're looking to have a gigabit connection at the tower with fiber, then we need to go to a gigabit broadband network gateway. And those products can be obtained in custom versions up to 10 gigabits, okay? The interesting thing about EasyWisp is that it comes with the software without charge, because the cost of the software is kind of bundled into the product. And so, as I mentioned, the overall cost, the operating cost, is much less than using systems like Visp.net. So it's an alternative. It depends really how much you want to pay. If you can charge your clients $100 a month, then paying Visp.net is no problem. If you're in a country in South America and your customers can only afford to pay $10 a month, then you can't really afford with Visp.net. You've got to go to a cheaper option. Okay, Inoza also asks, when you say unlicensed frequency, is it the perspective of the FCC or the ITU? Well, it's both. The ITU is the International Telecommunications Union, and so every country that signs up, they adopt the unlicensed frequency ranges of 2.4 and 5.8 gigahertz, and obviously the FCC also supports those as unlicensed frequencies. The difference is that in the USA, the FCC opened up the 6 gigahertz band as unlicensed, which is not part of the ITU range. You do have limitations, of course. You've got power limitations. You've got a maximum power of 36 dBm. In Europe, it's about 27 or so dBm, much less. And so that limits the distance. If you're a mobile phone telco, then you're putting antennas on top of a tower sector antennas, and you can maybe power those with 50 watts. And so you can communicate over a long range, like 5-10 miles. If you're limited to the ISM power, then you're limited to 36 dBm at the antenna, which is probably antenna with 10 dB gain, which means you're looking at 26 dB out of the transmitter, which is kind of Wi-Fi room levels. Now, the interesting thing is what Tirana did, because they've used those levels of power on a phased array antenna. You can actually communicate over the same sort of distances that a telco would communicate with a sector antenna feeding it 50 watts of power. And so you can see that technology will give you a big advantage even on unlicensed spectrum. Now, the problem with unlicensed spectrum is it's free for all. And so there's a lot of interference there. And so the better directional antenna you have, the less prone you are to interference. And so if you have a point to multi-point using a sector antenna, basically you're blasting radio frequencies over maybe a sector of 120 degrees with maybe a 5-degree vertical. And so you're going to get a lot of interference. Whereas if you go with a point-to-point antenna like a parabolic, then you're going to get much less interference, because there's the beam is so focused, it communicates over a longer distance. Now, Tirana, the advantage of that is not only that it's a phased array which can focus the beam over longer distances, you're also less susceptible to interference, which is a great benefit. The cost is higher, but the performance is much better. Okay, does that answer your question, Inuza? Do we have any more questions from anybody? I'm open to answer any more questions. You can unmute yourself. The microphone is on the bottom left of the screen. Just click on that to unmute yourself and go ahead and ask questions. Anybody else who wants to ask a question? Okay, well, don't forget the free book download. Yeah, was that somebody asking a question? Freddie, are you asking a question again?
Everything's good.
Or are you just unmuted? Nope. Okay. Well, don't forget the free download. And I want to thank my friends in Flytech for organizing this. They can provide you with a lot of technical information as well as product information. So thanks to them, you have my contact information if you want to call me directly. So please do so. So, well, thanks very much. I appreciate you all joining our presentation, and I wish you all a great day, and sign up with Flytech.